Hi, mathematicians. So last time we met, we worked on solving problems that involve elapsed time. Remember, elapsed time is the time in between something, or how much time was spent, or how much time you need between two times. So, or if you're trying to find a start time or an end time. Today, we're going to be continuing that work, but with solving some a little bit more complex problems. But I know you guys are up for the challenge. So let's take a look at our first problem. It says, Zach and his family are going to New York City. So when you guys think about these time problems, I really want you to picture it in your mind. Imagine you and your family are going to New York City or taking a trip somewhere. Their airplane leaves at 9:15 a.m. So that's when it's taking off, 9:15 a.m. Okay. They need to arrive at the airport 60 minutes before their flight. So think about it. If you're going somewhere, you need to get on a plane and you need to be there at least 60 minutes before. So, okay. It takes 15 minutes to get to the airport. Are you picturing that? So it takes 15 minutes just to drive there. The family needs 30 minutes to get ready to leave. Picture that too. You wake up, you're getting ready, it takes you 30 minutes. Then you got to drive to the airport and it takes 15 minutes. And you want to make sure you get there an hour before. At what time should Zach's family start getting ready? So basically, what time should they wake up to get ready and go to the airport? Now, the best strategy when using and solving these types of problems is to use a number line. But first, let's think about what do we need to find. So we need to find what time their family needs to start getting ready. So we're actually looking for the start time. We have the end time. We know the plane's taking off at 9:15. We don't know that start time. The information that's going to be really helpful for us is knowing that the plane leaves at 9:15. They need to get there 60 minutes before their flight. It takes 15 minutes to get there, and it takes them 30 minutes to get ready. And we're going to use the information, like I said, by using a number line. Or you can use an interactive clock. I'm going to do both. I'm going to keep track on a number line, but use the clock to show you what it looks like. So, since we know our end time, we're going to be counting backwards to find that start time. And our end time is 9:15. So let's think first. The first thing they said is they need to get there 60 minutes before. 60 minutes is the same thing as an hour before. So my first jump back needs to be an hour. So I'm going to jump from 9:15 and I'm going to go, oops, I don't know why it's like that. And we're going to go, like I said, an hour back. Okay? Now, if you don't know an hour before 9:15, we can use the clock to help us. Now, an hour is 60 minutes. Or you're just literally going to go backwards to the same. Oops, it didn't go. I'm just going to go backwards to the same spot. Or just think, okay, 1 hour back. So it would be 8:15. So we know they need to get to the airport at 8:15. Okay, so we used our one piece of information. All right, let's think about what's next. Remember, it takes them 15 minutes to get to the airport. So we need to go back. Our next jump needs to be 15 minutes back. So actually, let's take. So this is minus 15. That was minus an hour or 60 minutes. Okay, so 8:15, take away 15 minutes. Let's see. And picture it in your mind. I'm going to go back. 5, 10, 15. It's 8 o'clock. Doesn't that make sense? 8:15, take away 15 minutes. It's just 8 o'clock. So now it is 8 o'clock. That's what time they're leaving their house. But remember, it takes them 30 minutes to get ready. So we need to figure out what time they need to wake up. So my next jump is going to be back 30 minutes. So 8 o'clock, take away 30 minutes. Remember, we're going backwards. So I'm going to go back 5, 10, 15, 20, 25, 30. Or remember, half the clock is 30 minutes. You could have just went straight back. So it is 7:30 now. So what time do they need to start getting ready? 7:30 a.m. for their trip. Okay, do you see how we had our end time and we counted backwards to find our start time? We used the number line and the clock to help us. All right, let's try another problem. Go back to this. I'm gonna get my other board up and ready. Let's take a look. Okay. All right. Bradley gets out of school at 2:45 p.m. Are you picturing that? You're leaving school at 2:45. It takes him 10 minutes to walk home. So he's walking home. Then he spends 10 minutes eating a snack. He spends 8 minutes putting on his soccer uniform. Okay. It takes 20 minutes for Bradley's father to drive him to soccer practice. At what time does Bradley arrive at soccer practice? So what do we need to find here? Well, it's asking what time does Bradley arrive at soccer practice? We have our start time, which is what time he left school, and then we have all the stuff he did in between, and we need to figure that end time. What time does he get at soccer practice? The information that's going to help us is that 2:45 when he's left school, the 10 minutes to walk home, the 10 minutes to eat a snack, 8 minutes getting ready, and 20 minutes driving there. So we're going to use a number line again to help us solve this. But this time, since we know our start time of 2:45, we're going to be counting forward. So I have 2:45. And let's see, the first thing he did was he walked home. It took him 10 minutes to walk home. So 2:45 plus 10 minutes. You can either think, okay, plus 10 more minutes, that's 2:55. Or if you're not sure, use the clock to help you. Let me just set my clock to our starting time, which was so close. 2:45. Okay, and I want to go forward 10 minutes. 5, 10. Okay, so it is 2:55. All right, so we took care of that. But then remember, he also ate a snack for 10 minutes. So we need to do another 10-minute jump. So you can either think, okay, if you know that, if not, just count forward 10 minutes. 5, 10. Look, it's a new hour, right? Because there's no such thing as 2:60. So it turns to 3 o'clock here, and now it's 3:05. Okay, let's see. What else did he do? So we talked about him walking home. We talked about a snack. Oh, then he starts getting ready, and that took 8 minutes. So I'm going to do a jump of 8 minutes. Now, you could either think what's 5 plus 8, or you can use your clock to help you. So I'm going to go first to 5 minutes, and then 5, 6, 7, 8, and it is now 3:13. All right, we're not done yet because he has to drive to practice. And let's see, it takes them 20 minutes. So I'm going to do one more jump of 20 minutes. Okay. And you can either think, okay, what's 13 plus 20? Or you can use the clock. Now that's not, so I'm going to think, okay, this is 1, 2 minutes. Okay, so I still need to go 18 minutes. So I'm going to go, that's 5, 10, 15, 16. Oh, wait a second. Where did we end up? So we left off at 3:13. Okay? Oops. Yeah, 3:13. Now, I like to think I need to go 20 minutes. So I'm going to take away 2 here. So I like being on a nice even spot. Now I need to go 18 minutes. So I'm going to go 5, 10, 15, 16, 17, 18. So it is 3:33. And you can check your work by thinking, okay, 13 plus 20 minutes. Oh, that equals 33 anyway. So that makes sense. So he arrives at soccer practice at 3:33 p.m. So mathematicians, do you see how it's really helpful to use a number line and to really picture the problems? You can use the number line and your clock to help you figure out. Okay? All right, guys, off you go.